Okay, question number 14. We have two trapezoids below that are similar, and we need the height of the larger trapezoid. All right, a ratio and proportion or scale drawing, and we will see a good many of these, and it's important for us to come up with some strategies and some methods on how to best answer these. First one I'm going to walk you through, there's really three different ways we can do this that I look at, and first one I'm going to walk you through is just kind of trying to reason through the figures and see, we're given four choices to see what we can't come up with. So we are missing, marker here right quick, so we are missing this side is the only one that is missing, and it corresponds to the 24 on the smaller figure. Now these are similar, which means that however many times bigger one side is, all the other ones are going to be in the same proportion to each other from the smaller figure to the larger figure. All right, so we look at this side. This one corresponds, the missing side corresponds with the 24 over here. Now we look at how these sides are ordered. This one, 24, falls between 20 and 26 as its measure, and 30 is the largest. So it's above the smallest one, but in the middle of it and the next to the largest one. So as we look over here, 45 is going to be the largest side, 30 is the smallest, and this side is going to be between 30 and 39 as its measure. So we can rule out any answer choices that are not between 30 and 39. So 16 can be ruled out, and then 30 can be ruled out because it's got to be between 30 and 39. So it has to be larger than 30 but less than 39. Now we can look over here, and this is not a scientific way of doing this, but we can see that this is 24 and this side is 26 and the smallest side is 20, so it's a little closer to, and I'll put a circle, it's a little closer to this measure than it is the smallest side. So it stands to reason that in the larger figure it should be a little closer to the 39 than it would be the 30. And the answer choice that's a little closer to it is 36, answer choice D. Right? Let's look at it from a scale factor point of view, and let's try to figure out how many times larger is the larger trapezoid to the smaller one. So let's take a corresponding side of 20 on the smaller, and we will compare this 20 that I highlighted here to the 30 to find out how many times larger it is. And the way we do that, we'll come over here to the calculator. We'll take the larger side and we will divide it by the smaller side, and we come up with 1.5. Or you could have maybe looked at that and said, well, if it's twice as big, it'd be 40, but it's not twice, it's only half as big as that would be, so it'd be 10. So it'd be the 20 plus another 10. Half of 20 would make that 30. You may look at it that way, or now we found the scale factor. That's what the 1.5 is, represents on the calculator now. That's the scale factor. So we could multiply that then by the corresponding side on the smaller figure of the side we're missing. As we said, everything's in a constant proportion or ratio here. And so we could do equals, and that equals 36. All right, so that's how we determine a scale factor. So we divided quickly the larger side by its corresponding smaller side. So we divided 30 by 20. Got a scale factor of 1.5 and multiplied that by the corresponding smaller figure, 24, to come up with a side of 36. And the next way of doing this would be to set up a ratio and proportion. So we may set up, and I'll come here, we may set up where I'll use S for small figure and the side that corresponds to the large figure. And we may set it up like that. So here's kind of a method I use to set up my ratio and proportions. All right, one is going to equal something else. I'm going to take my small and I'll set up the 20. So the 20 in the small corresponds to the 30 in the large, and the 24 in the small corresponds to what we don't know, the unknown, right, in the large figure. And so now we have set it up small or large, and there's a couple of different ways you can set up the ratio and proportion, but as long as you keep everything in order, you'll always have the same answer. So we solve this by whatever is across from each other, we will multiply, and then we will divide by what remains. All right, so we cross multiply and divide is what we say. So let's clear the calculator out. We will do 30 times 24, and then we will divide that number, find that, by 20, and that equals 36. Voila. And this is basically the same thing we did by finding the scale factor before and then multiplying by the missing side. It's the same type of calculation. It's just that we've set up a ratio and proportion. So those are the three ways we can solve those. A lot of times you will be able to, if you can just put your sides in order, kind of get a relationship in the figure to one side to the other sides in the figure it's in, and then look at the other figure and kind of try to do some comparison, look at your answer choices, and sometimes you can reason through and you don't even really have to do any math. But we can find the scale factor, as we said, dividing the larger one by the smaller one and then multiplying by the corresponding side, or we can set up a ratio and proportion. Those two ways will always work. Just take your time on these questions and think them through, and you'll be fine.